guys, welcome back to Michelle's STEM Journey. I am Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2007 10A Problem 12 and it deals with permutations and combinations. I hope you all enjoyed this video and let's get started. The problem states 2 tour guides are leading 6 tourists. The guides decide to split up. Each tourist must choose one of the guides, but with the stipulation that each guide must take at least one tourist. How many different groupings of guides and tourists are possible? So looking at the problem, I am going to call guide 1A and then the other guide B. And so this sentence right here is very important because each guide must take at least one tourist. So that means that it is not possible for all 6 of the tourists to go to one guide. And so because there are only 6 tourists, we can actually just go through each one of the possibilities. And in this question, we are going to be using combination. And it is when a selection of things in which the order does not matter. And so the formula for that would be this. And so this refers to the selection, so the number of combinations, and then N is the total number of objects. And in this case, we have 6 tourists because that would be the total number of people. And then R refers to the number of choosing objects. So I'm just going to give an example and you'll get this a lot more. And for those who don't know, this exclamation mark in math means factorial. So for example, the factorial of 3 would be 3 times 2 times 1. And so basically it's just multiplying it consecutively numbers that are like decreasing from the starting number all the way down to 1. And so starting off, for example, I'm gonna let guide A have 1 tourist and then guide B will have 5. And so in this case, 6 would be the total number of people, and in this question, it will always be 6 at the top, and this is how you're supposed to write it. And then at the bottom, it would be R, so the number of choosing objects. And so we can just solve this using this formula right here. So it would be in factorial, so 6 factorial over R factorial, so 1 factorial times 6 minus 1, which is 5 factorial. And so this would give us 6 times 5 factorial over 1 factorial times 5 factorial. And the reason why I'm not solving all of this out is because we see here that we can actually cancel out 5 factorial in the numerator and denominator. And so this leaves us with 6 over 1 factorial, which is 1, so it would give us 6. And so this would be the number of ways to arrange the tourists under this scenario of guide A having 1 tourist and then guide B having 5 tourists. And then we can increase this and then decrease B, so it would be 2 and 4. And it's the same process. And then so we would get 15 ways to arrange the tourists for that. And then we would end up with 3 and 3. And then for the last two, when A has 4 and B has 2, and then when A has 5 and B has 1, it's the same as the first two, because if we do 6 and then 4, if we write it out, we actually get the exact same thing as previously. And so the answer would be the same as well. So it would be 15 and then 6. And so these are all of the different ways, and all we have to do now is just add them up. We would get 6 plus 15 plus 20 plus 15 plus 6. And so this would give us 62. So the answer would be D, 62.